3-1, 3-2, 3-3 was the stuff that was on your quiz, and most of you did pretty good on those quiz questions. So I would just say make sure you review that stuff, like the difference between perpendicular and skew, that kind of stuff. That it's been a little bit since you looked at it. In 3-4, you had those like weird theorems. Hang on. All right, so I would say like those 3 theorems that, first of all, the linear pair perpendicular theorem, it has like the linear pair part in its name. Hopefully that one's, I feel like it's the bottom 2, perpendicular transversal, and then lines perpendicular to a transversal. But think about what it's actually saying, right? Like the one that says lines perpendicular to a theorem is saying there are 2 lines that are perpendicular. So for me, that helps. Like the extra words on the front means that there are 2 lines that are perpendicular to this third line, which is the transversal. So if 2 lines are perpendicular to that transversal, then they are parallel. So for me, it's that part, like the part that says lines perpendicular to a transversal. That kind of describes what it is you're saying. You're talking about 2 lines that are perpendicular to a third line. Whereas, hold please. Whereas the perpendicular transversal theorem is saying that there is a transversal that is perpendicular to one line, one of 2 parallel lines. So then we know it's perpendicular to the other one also. If it's the wording, like in the title, that's throwing you off, then you can always write it out. Like if I'm trying to prove that these 2 lines, if I'm given that this is perpendicular to this line, and then I'm given that these 2 are parallel, and my goal is to prove that J is also perpendicular to K, then I can even say if J is perpendicular to H and H is parallel to K, then J would be perpendicular to K as well. And you could literally write the words out. You could also say that if these are parallel, that if this is angle 1, angle 1 and angle 2 would be congruent because of the corresponding angles theorem. And then if they are congruent, then those lines, then the 2 would also be 90 degrees, and then you'd have perpendicular lines. So it's not always that you have to use this exact theorem. You might have to work around it a little bit differently. As long as you understand what it says, don't stress too much about the words that are the name.
So we can just write it out.
Sure. Yep.
Wait a minute.
I had a question before.
Like it'll either be marked as parallel like those 2 are, or it would say it over here like H is parallel to K. So you definitely have to read the instructions. Kala.
So what are they trying to prove?
In that one, you're trying to prove that J is perpendicular to K.
Because I'm not confused about the names. I'm just confused on what it's saying.
So perpendicular transversal theorem is proving a second pair of lines are perpendicular, whereas lines perpendicular to a transversal theorem are proving that 2 lines are parallel. So the first one is that if one is perpendicular to a parallel line, then the other one is also perpendicular to it. Whereas that last one, the line's perpendicular, the long one, they're both perpendicular. So if they're both perpendicular to the same line, then they're parallel. So that's one of the 6 ways to prove lines are parallel. Mars.
For the linear pair perpendicular theorem, they're always going to be 90, right? The linear pair has to be 90.
They don't have to start 90. No, you would be proving that they're 90 because they're perpendicular. They have to be congruent. So they have to form a line and they have to be congruent.
But if they're congruent, then they can only be 90.
Which is exactly what that theorem says. You could get there the long way around. I could say if these 2 are congruent, right? I could say angle 1 and angle 2 are congruent if I'm given that, right? Given angle 1 equals angle 2. Then I can say angle 1 plus angle 2 equals 180, and that's the linear pair postulate. Actually, I would say that they're supplementary if I want to do it the long way. They're supplementary. That's the linear pair postulate. And then they add up to 180. That's the definition of good. And then if they are both the same, I could swap in one for the other. So I could say angle 1 equals angle 1 plus angle 1 equals 180. And that's substitution. I could say 2 times angle 1 equals 180.
You are doing
Now you're just like...
I'm saying you could go a whole long other way instead of using this, right? And then I could say angle 1 equals 90. So that whole thing gets taken over by linear pair perpendicular theorem. So you can get there a long way and say that they're equal. So then they'd have to add up to 180, they'd have to be the same, which means they're 90, and if they're 90, then they're perpendicular, right? Because I could go, then it would be one more step. Or you could literally go from start to finish on this one and say linear pair perpendicular theorem, which it's not going to be a one-step proof, okay? There is, again, one that's partially filled in and one that's open-ended. The open-ended one should not take you a lot of steps, but it's not going to take you one.
Actually, no, I don't want it to be one. So what if I just get it wrong?
Yep, true.
Then
Has to at least be two
because
steps.
If you have like multiple steps, you have a chance of getting partial credit added.
All right, any questions on 3.5, which was the equations with the parallel and the perpendicular lines?